So guys, unless you speak to me, keep your phone on mute, and thank you, and that all you could join, and appreciate your attendance, and very welcome to the class today. We will do class today for like in 1 hour and so, and we'll finish class after that. Today I wanted to talk about system development lifecycle. We talked about this briefly before, but I want to talk again what is system development lifecycle is all about. What does the system development lifecycle consist of? So system development lifecycle, and what are the different phases, different activities, different tasks, different role responsibilities which are involved in software development lifecycle. And the very interesting part of the software development lifecycle is that most of the, whether we talk about SAP, whether we talk about anything else, software development lifecycle remain fairly constant and consistent. It is being used in same way in all different aspects. Software development cycle is pretty common. And another thing which you will observe and you will find is that although we feel that we have a lot of different terms, different terminologies, you will observe, but one thing is for sure, that almost entire and most of the software development life cycle remain same. So software development cycle remain fairly constant, consistent, and is standard in most cases. Let us talk about what is the software development life cycle is. The definition of software development life cycle. Understanding how an information system can support a business need. So any business information system we are developing, ultimately at the end of the day, there is a business expectation, business need, business requirement. And for that business requirement, we are creating an information system. We design the information system. So we understand requirement, we do the designing, and we build the system, and we deliver the system. So when we talk about software development life cycle, in every or any life cycle for that matter, these four roles remains fairly constant, which is understanding how the information can support business requirement, how we can design a system. Now what is the designing? Designing basically means if I have this business requirement, then for this business requirement, how many tables I need, how many programs we need, what kind of programs we need, that is designing. We build it, means we do the programming, etc., and then we deliver that to the business users. So eventually, ultimately, all business cycles consist of these four phases. Let us talk about it in more detail. Different phases of software development life cycle. Essentially, in order to achieve the four goals which we talked in the last slide, we have these 5 steps. Step number, we do the planning. that if I have to do this business solution, then why are we doing this business solution? What is the business case? What is the ROI? What is the business value? Why we are doing what we are doing? Okay. And that is all part of ROI. The second part is analysis. In the analysis, we determine that who gonna do it, what we gonna do it, what is the location, when, what is the timing, how long it will take, what is the duration, how many people will be involved, who will be involved, what is their role responsibility, who is going to project manager, how we going to hire the resources, are we going to hire from outside? That is all part of analysis. It's part of analysis. The next is, guys, the design. So how the solution gonna look like? Design. How many tables? How many screens? How many forms? How those screens gonna look like? What is the sequence? What will come first? What will come second? That is design. Implementation is building the solution. Evaluation, making sure that whatever solution we have developed, that is conforming to ROI. Conforming to ROI basically means whatever we created the solution because there was a business value in it, whether this business value is being met or not met. That is part of different phases of software development life cycle. Okay, 1, 2, 3, 4, 5. At the end of the day, in all implementations, all software development life cycle, all phases, ultimately, these are the 5 steps. Remember these. All software development life cycle of the world, ultimately, you might find in, you go to different projects, you will see different names, different phases, different fancy methodology, different, and some of those fancy methodology I'm going to talk as well. But ultimately, software development life cycle consists of these 5 steps: planning, analysis, design, implementation, evaluation. Let us talk about that. System development life cycle: planning, analysis, design, implementation, evaluation. 5. 5 of them. Five of them. In the planning, we talked about what we want to do. Initial investigation, understanding the solution. Do we really need to do it? What is the value? What the project going to do? How long this project would be? And then feasibility, can we even do it? Is it going to be costly? Is this affordable? Can we do it in our cost? Can we put into the solution? Can we put into our in our expectations? Can we do it in our budget and our resources? Our feasibility. So feasibility is the possibility. हाँ जी निशी जी सत श्री अकाल हाँ जी सत श्री अकाल जी मैं क्लास हाँ जी असी क्लास में हैंगे जी जी जी, हाँ जी, हाँ जी, सत श्री अकाल जी, सत श्री अकाल, ओके बाय. So planning, analysis, design, implementation, evaluation. In the analysis, basically is a business requirement gathering. Business requirement gathering. Business requirement validation. Business requirement documentation. What I want to do. So see the first thing, what has to be done? What I'm going to do? What are my business expectations? What are my business requirements? Detailed business requirements. And then see, next step we do design. System design, technical design. System design, technical design. Technical design is done more from the programming perspective. System design is being done more from the system architecture and more from the system flow perspective, from the process perspective, from the document perspective, from transaction perspective. So in the system design, we can see, okay, how do I want system to look like? How many forms? How many programs? How many views? How many reports? And technical design means doing a actual pseudo coding. Pseudo coding. You're not doing coding, but defining the logic. Technical design, one simple and typical example of a technical design could be, I'm defining a definition of the table, that how this table will look like, how this table will look like, how many fields would be there in this table, how many columns, how I'm going to maintain. That is technical design, where you're doing actual designing of database, for example, pseudo coding, for example, logic, for example. And implementation, when you actually do the coding, where you actually build the solution, you test it, making sure that solution which you developed, that solution meet business requirements. And you install it, you go live, and then we have evaluation. Evaluation basically means making sure that system which we have developed, programs which we have written, application which we have evolved, purchased, configure, is working to our expectations. Those business benefits which we expected from the solution to come, those business benefits are being met. Now here also we see the primary responsibility. The color has some meaning to it. You see this slide is fairly colorful because these colors have meaning to it. This bluish color means done by the business people. Yellow color done by the system people or technical people. And green means is a collective responsibility done by both. So that is why these colors which you see at the screen have the meaning to it. Let me tell you. You will see SAP implementation or this implementation, that implementation, whatever implementation of the world. Fundamentally, all those implementation life cycle are what you see at this screen. You will see a lot of methodologies, I'm going to talk about some of those methodologies myself in this class, but eventually all these methodology come down to these 5 steps in the life cycle: planning, analysis, design, implementation, evaluation. Okay. SDLC, I will like you guys to make a note of that. Each phase consists of a step that lead to specific deliverables. Each step of the phase rely on the technique that produce a specific document, files that produce understanding about the project. So we talked about there are 5 phases. Yeah. Each phase has a specific activities. Each phase has a specific deliverable. Please make a note of this paragraph. Who did this? Why you're disturbing his face like this? I don't understand. क्या डाल दिया इसके फेस पे क्या लगा दिया मिट्टी क्यों why you are what इसके मुंह पे बोल दो किसी के पास नहीं जाना है ओपन अप yes go ahead normally ideally what deliverables you're gonna do and how is deliverable gonna look like, ideally it should be defined during planning phase. Okay, I'm sorry, during planning phase. You see the planning phase? Yeah, during planning phase we have to define these. So ideally, yeah, go ahead. No, first you go ahead. You have a both also, right? Right, right. Yes. Yes, sure. So in each phase, you have a different set of steps and you have a different set of deliverables. Now, ideally, as I was mentioning, what deliverables you're going to look like, how this deliverable template is going to look like, normally being decided in the beginning of the phase. Normally on the different projects, every project have their own templates and all that. And it's a very fair question to ask during implementation process. Say, yeah, what is the template for BRD? What is the template for FSD? You can ask that. With some of these templates and all that we're going to see as well, we're going to review as well, we're going to do as well in our class 2. Now when we talk about the BRD and FRD and all these different deliverables and different, but actually even if we decide, and ideally it should be defined in the beginning of project, but there is always a little bit of a fine tuning which keep happening during implementation as well. System evolves through gradual refinement. Like any evolution, understand this also very important statement. System evolution, application evolution is also an evolutionary process. It's a gradual process. It is not 0 and 1. It's not black and white. It go a gradual evolution development process. And that is what happens. And that is happening in SAP too. So gradually we are developing these applications. So the development process, evolution process, build process, configuration process, programming process is gradual. Planning. So we talked about the first phase of any implementation, you plan. And in the planning, the very first thing you is why. Why you want to do that? What does the business need? What this solution will do? What business objective which is going to achieve? What is my ROI? What is my business case? What I'm going to get in quantitative and qualitative benefits? And how? How? How basically means how long this project going to be, how many people I need, what going to be the duration, which solution we need, what kind of resources we need, how many resources we need. So there is a why and how. So both of them we discuss. So in how we also take cost, we're going to take increased revenue, and then we also have how, and that basically means who is going to be project manager, what is my work plan, how long this project, who's going to do, and this is why, this is how. You also have an initial deliverable. You have a high level requirement. I'm going to develop a procurement system. So we don't know in detail, but we know that what are we expecting. We know what we want from this system. We know what are we expecting. We know what kind of system we want. So initial expectations, initial business requirements are there, would be there. You identify the business clearly, what kind of business problem is going to solve, what is going to be my investment, how am I going to get my money back. Feasibility is technical, what solutions I need, whether we can even do it, is it affordable, is costly, is my organization can afford it, is going to make too much impact, do I even have a people to support this implementation. All these feasibility activities being performed. You also develop the work plan, which basically means you develop how long this project will take, who is going to be staff, how many people, how many staff, how I'm going to control, manage this project. Planning. Analysis. In the analysis phase, we also determine what kind of data would we require. Performance level. One of the common example of performance level could be how many users I'm expecting this system can be accessed by. I want this system to be accessed by 5 people or 500 people or 5,000 people. Because based upon that, why might have a different. Do I go to do the business user in one location, or we have a 15 countries where people can access this performance level? And then when you're doing a requirement, you can also say, we're going to do some of these procurement. First I want to do US, then I want to do Canada, then I want to do Mexico, then I want to do Europe, then I want to do Asia. Prioritization. I want to do this whole procurement system, but this is the sequence I want to do. This is my priority. The first priority is to do this in US. That is what I want to do first. Then we also define project teams. Analysis. You also say, but am I going to use some kind of standard solution, or this is going to be non-standard solution? What kind of system this is going to be? Analysis. What is going to my business requirement? How I'm going to business requirement? I'm going to do interviews, I'm going to do meetings, I'm going to do questionnaires, data modeling, system proposal. So what kind of system we want? Eventually analysis. High level. In analysis phase, we are gathering business requirement, use cases. Use cases is basically an example of a requirement. In the requirement, when we talk about the use cases, we also identify a couple of other things, which is number one, we identify processes, we identify data. So we are doing both process modeling and data modeling. Now, when I say process modeling, I'm talking about the business process modeling. In the business process modeling, we are talking about how the process flow gonna look like. So for example, when customer comes, he can place an inquiry. From the inquiry, he can place in a quotation. From the quotation, he can place an order. From the order, we can ship it. From the shipment, we can do invoice. That's a process flow. How that flow will look like. And see here the word Visio, Microsoft Visio. Microsoft Visio is one of the very commonly used product for doing the process modeling. Is very, very commonly used in the industry. We also do something called data modeling. In the data modeling, we also look like how the data gonna look. What we would do in data. How much data would be required? What kind of data? How much data? What different data elements? So, example. So in this system, we have a customer data, we have item data, we have vendor data. In the item data, I want this information. In the customer data, I want this information. Vendor data, I want this information. And how much? I can have 10 million customers, or I can have 50 customers. We don't know. That is an example. After the planning, analysis. So planning, analysis, and design. So in analysis, if I overly simplify in analysis, we are capturing, gathering, documenting all different requirements. Detail out. All business requirements are gathered explicitly black and white in English, in process flow diagram, in data flow diagram. If I have to say that what is the one probably the most important output of the analysis phase, I would say I have validated, documented, detailed, comprehensive business requirements. That is the significant output of this phase. Design. So now we got the business requirement. And now we have a design. Now we have a design. Design basically means for these business requirements, now what we need to do? Do we need to configuration? Do we need to develop some forms? Do we need to write some reports? What kind of software we need? What kind of hardware we need? What kind of infrastructure we need? We have a design strategy, in-house or outsource, means cloud-based solution, or I need to go buy a software which will be physically installed in our premises. Architecture design, what kind of hardware I'm going to buy, what is going to be my network specifications. So design strategy, I'm going to have my architecture design, and so on and so forth. Interface and program design. Interfaces. Now what is interfaces basically means? Interfaces basically means if I have a new application which I'm developing, I might have an interface for the future. In the current system and the future system, how the architecture going to work? Is both of these applications going to be integrated? Do we need to integrate them? How that integration going to work? Data storage design. How I'm going to store data? What is going to be my RDBMS? Relationship Data Business Management. XML. Do you know what is the extension of XML is? How many people know what is XML stand for? What is XML stand for? Anybody knows what is XML stand for? XML. PDD means process design document. Kiran. Imran, you asked me that question. PDD means process design document. Hyper markup language? No. Extensible markup language? Yes, that is correct. Extensible markup language. Please make a note. What is XML stand for? Okay. Yes, I told it. FDD, functional design document. Functional design document, that is FDD means. By the way, these are not curse words though, Imran. You guys was me thinking this these FDV, PDD, there's some kind of curse words. That is actually not true. Okay, what is FSME, functional specification document? There are a lot of terminologies. So FSD means functional specification. Oh yeah, is also here, functional specific document. Um, keep asking any other question you might have. Okay, implementation. Implementation. Implementation basically means when you are implementing a solution, you might have a solution which you have either developed. Develop basically means which you have done your own programming, or something which you have purchased. So purchase basically means which you have standalone application. So that is the packaged or purchased item. So we have a developed or purchased, yeah, either of them. This phase has a 3 steps. This implementation consists of 3 phases: construction, installation, and support plan. Make a note of these 3 terms: construction, installation, and support plan. Make a note of these 3 terms: construction, installation, and support plan. Construction, installation, and support plan. Now, construction basically means when you are configuring, doing a programming, and after configuration and programming, you are also doing testing, where you test the system. You do a physical, actually testing it. Okay. Installations. Where you install the system, you train on the system, and afterwards you support, making sure the people can use it. Support. Okay. Let us understand this more. Evaluation. In the evaluation, did this solution meet our goal? That, how we can improve in the next project? What is our lesson learned? This basically means our lesson learned. What went right? What went wrong? how we can incorporate, what we can change. Remember, development evolution is a constant process, is a continuous process, is a daily process. It does not stop. It never stops. It keeps going. What benefit we are getting? Are we getting any benefit? All these things which we did. I would like you guys to make a note of this term. Please make a note of this term. The first bullet point. Please make a note of that. Okay. So methodology is a formal approach. Formal approach. If I am going to implement a solution, how we will implement? That is methodology. Methodology can change. Methodology can vary. Methodology can be fine-tuned. There is no, the common broader components of a methodology remain constant, but methodology by itself is never fixed, never constant. It always evolves, it always change, and it would always change. That is the purpose of a methodology is. That is what methodology does. They are not constant elements. And it is never that way. It will never be that way. Even if I'm using one methodology in one project in same company, in the next project, there might be some fine tuning to it. Because you always learn. You remember in the last thing I would say, lesson learned. You always do that. What went wrong, what went right, and then what is the change. So that is an example of life cycle versus methodology. Let us understand this concept of system life cycle and system development methodology. Let us understand that. System life cycle consists of two fundamental stages, two fundamental demarcations. It consists of the first, the system development, and second, once it has been developed and deployed, we continue to use, we continue to operate, we continue to maintain, we continue to use, understand, evolve, develop, question, improve, improve, improve. We continuously keep improving this. Now, what is the system development methodology? System development methodology is a formal approach. That is formal approach for the system development. How system should be developed. Should be developed. What different phases we should have, what different activities we should have, how those activities should be performed. If I'm doing a business blueprinting, for example, so we have a activity called business blueprinting, but then how do we do it? What kind of a methods we use to do that? What is the better way of doing it? What are the different deliverables? What are the tools we will be using? How are we going to do project management? And all those things are included in system development methodology. Okay. Structured design. I would like you guys to make a note of this first paragraph, which is I put into the red color. Structured design. Okay. Structured design. Pay attention to the word structured design. Structured. Structured. Design methodology adopts a formal, step-by-step approach to the software development life cycle that moves logically from one phase to next. So if I'm doing an implementation, then how those implementations would be done? What are the sequences? Logical, formal sequence. Methodology also introduced formal modeling, diagramming techniques, some of them we'll understand, describe basic system processes, and follow a structured design technologies and tools. A formal, structured approach to a software development. A structured, formal approach to software development. There is something called waterfall. Make a note of that. Waterfall software development lifecycle model. And make a note of the bullet point number 2. Waterfall software development lifecycle model. An approach to system analysis, design and development that complete one phase after another and only once. Let's understand. We are talking about waterfall software development lifecycle model. Waterfall. Remember, water fall from top to bottom. It does not go back from bottom to top. Yeah? It is only unidirectional. Goes from top to bottom. It flows only one direction. So you do one phase, complete that, sign it, go to next phase. Complete that, sign it, next phase. Complete that, sign it, next phase. And you do that phase only once. You don't go back. This is a linear development method. It is sequential in the method. It is linear, sequential. Advantage. So you have all requirement identified before you do programming. Changes are minimized. You have a better control. Not much of overlapping and iteration is not there. You don't go back. You're done with the phase, you're done. You move on. You don't go back. And disadvantage, it does not allow revision. Once you sign off the phase, you sign off the requirement, those requirements are signed, fixed, firm, complete, closed. You don't go back. And then after you go the requirement, you do the programming. Once you do the programming, you test it. Once it's tested, solution is developed. You do not go back. You do not go back. This is the waterfall methodology. You do planning. Planning is complete, go to analysis. Analysis is complete, you go to design. You complete design, you go to implementation. You go to implementation, go to system. Waterfall. You done one phase, go to next. Then you take next phase, done next, and finish. Waterfall. Go ahead. Sequential. So this methodology assumes that once you do analysis, most of your business requirements has been documented and validated. Having said that, it is possible that some of the business requirements can be further come on in the picture. So a lot of people do something called change request process, in which a new business requirements can be incorporated. But this approach is not iterative. Changes are highly synchronized, approved, validated, and only after certain changes any further change is incorporated. So in this methodology, although change can be incorporated, can be included, but it is not having a very extensive scope of changes. Therefore, in this methodology, for example, business blueprinting is very important. Its comprehensiveness, it is its completeness, it is the degree of depth is very important. Okay, so guys, I have a great news. And what is that great news? Anybody knows? Anybody there on the phone? Except Neelam Shah. So appears nobody's there. Really? I don't see anybody talking. Looks like everybody logged in and run away. Okay. So Kiran is here. Oh, okay. So a couple of people are there. Oh, NSCs are there. Okay. So like 4 or 5 people are there out of 18, 19. Okay. So at least 4 or 5 people are attending class, which is good. So wonderful. So we stop the class today and we'll again do the class tomorrow. Now because of the weather, tomorrow class will also be online, and then we take it from there. And talk to you guys tomorrow at 3 p.m. in BA class. And I thank you all, and I appreciate all you guys do. Thank you so much. Bye guys.